integration is really finding the area bounded by a curve. And the x-axis. Okay? So integration is really the area bounded by a curve and the x-axis. Does that make sense? So I'll show you what that looks like. I'll show you what that means. You've got a set of coordinates, and you've got another function. Let's call this a red function, and that is f of x, right? Y equals to f of x. Got it? Now the area bounded by the curve let's say, for example, how do I put that? All right, cool. All right, so now here's how we write it, okay? So let's call this point one boundary, and this is another boundary, yeah? Under this curve. If you want to find the area, we integrate. Got it?
Okay.
Yep. So integration is the process of finding the area under this curve.
Why do we want to find the area?
Sometimes you do want to find the area, okay? So, do you know how to find the area of, say, for example, hang on, yeah. So the area of a circle, for example, right? We can find the area of a circle, right, or a semicircle, right, using integration as well. Okay, so basically, if you've got an irregular shape, but it follows some curvy pattern, right? So if you want to find the area of some irregular shape, then integration is your most is one of the ways that you do it. Okay? All right. So I'll show you a little bit about how we do this. If that point there is x equals to a, right? And this point here in black is x equals to b, right? And this function is y is equal to f of x. Got it? Then the way we find the area, or I, right, which is another word for area, right, under the curve, it's basically, now there's that symbol there, which stands for sum, okay? It's the integral sign. That's the integral sign, okay? Now, it's from x equals to a to x equals to b. So it's from the bottom limit a to the top limit b. Got it? For the function f of x. Okay? And that's f of x dx. Now, I just want you to get used to the symbols. Okay? So when you see this, I know it looks freaky because it's kind of got all these symbols you've never seen before. But I just want you to understand this. All this means is that we're finding the area under this function, f of x, area under this line, or this curve, between x equals to a and x equals to b, right?
Yeah.
Okay. And the dx is just there to sandwich the function, okay? So it's the dx and the integral sign, they're just there to sandwich everything in. They do have a meaning, right? But we're not going to, I'll explain the meaning later on. when you see this, it just means the area under this curve between A and B and the x-axis. Does that make sense?
Mhm.
Yeah. Now, oftentimes, you won't get this. You won't see this. That won't be there. All right? And that won't be there. All right? Now, if it's just between A and B, like that, all right, then what it is between this letter here, x equals to A, and x equals to B. Does that make sense? Or this letter here. This letter and that letter should be the same. Got it?
Okay.
Yeah. Okay. Now, what would this be? So for this graph, S and T, all right? And let's give it a 2 and 7. How would you find this area? Okay, and y is equal to g of t. Can you write the symbols that would give us this area? I, because that's the integral, right? Which is another word for area. Yep.
And then sum.
Mm-hmm.
What is like the A bit for this graph?
Okay, we'll have a look. Can you see it?
No.
You can't see it? The number 2.
Oh, I just have to move my. Okay, yeah.
Yep.
So, 2 at the bottom,
Yep.
and then 7 at the top,
Yep.
and then G T
Yep.
DX.
D. This letter and this letter should be the same.
Okay.
So it's D.
T.
DT. Got it? Cool. Now, that's basically the notation to work out the integral. Got it? That just means the area under this curve. Okay?
Yeah.